Everybody, my name is Chad Mason, and I'll be talking about additive manufacturing applications in aluminum in the space and racing industry. First, I'll be covering Airbus Defense and Space, and then we'll go on to BMW. So Airbus Defense and Space, they're part of Airbus, as you heard earlier, but they're Europe's #1 in defense and space. They're among the top 10 in the companies in the world as far as defense goes. Their location, their headquarters is in Germany. Their website is right there. They are roughly about 40,000 employees. This is the defense side. Their revenue is about 14 billion in euros. Typical business interests for the space and defense is obviously military, space, communications, and then some other types of electronics. So I kind of touched on this prior in the term, but they developed a structural bracket using aluminum, using the direct laser metal sintering, and they used a EOS machine. They used the powder ALSI 10mg. The bracket is to hold on instrumentation that goes on the outside. So the photo on the left is the original design, and then the center one is kind of, it shows the design that they used with kind of like an overlay of what the original one looked like, and then the one on the right is the one that they designed. And then the photo down there on the right hand side, that's the actual satellite, and I believe it's a E3000. It's pretty standard, but like I said, the bracket is for mounting equipment, antennas, satellites. Why was additive manufacturing beneficial? It's 35% less in weight. It's 40% stiffer. They could also do a redesign. So the original part comprised of 4 separate parts, 44 rivets. So it took a lot of man labor, and so now the new design is a one piece, and it almost has no waste generation with it. Alternative, like I said, the 4 separate parts, putting 44 rivets in. So the new design is saves a lot of time. And then we move on to BMW. Their headquarters, Germany. Revenue 76.8 billion in euros. 106,000 employees. I believe that's worldwide. And they build cars, they build motorcycles, and they're actively involved in the racing industry. The car shown on the top left is actually a car that's racing around with an aluminum additive manufacturing part in the engine. So the part they actually made was a water pump. It might not sound very crucial, but it is. Material, they used an aluminum alloy. They didn't actually specify what type of aluminum. I would assume it'd be ALSI 10mg, maybe not. I don't know. The process they used was selective laser melting. So the part is shown there on the left, and then the photo there on the right is kind of shows the part and then the car behind it. So the application, the water pump. So this water pump is actually 75% of the time it is under a full load. So that's while it's racing. It replaced a plastic design that was, I believe, injection molded, and they replaced it in 2010. And so from 2010 to now, so the last 5 years, they made 500 end use. It was beneficial because it allowed design flexibility. So when the original part, since it was plastic, if they did any changes internally, they would have to get new tooling, new molds, that sort of thing. And so now they can design on the fly, make changes on the fly, and saves a lot of time. And so the new design is a single piece aluminum, and it offers optimal aerodynamics. And the alternative was the plastic molded part. And there's my references.